In this video, I need to find the roots or solutions to this function. So we need to take note of certain things of this function. So the first thing I see is that it's a third degree function, so it's not a quadratic. So this is a cubic, which means that it's a degree 3. So this degree of 3 right here tells me that I should have 3 roots. Okay? So typically we think of roots, a synonym of roots could be zeros, but I'm calling them roots for a particular reason, and we will see. So when I'm asked to find the roots of any sort of function, that means the first thing I should think of is I need to factor. So let's look at this. I have how many terms? 1, 2, 3, 4. So I'm going to try factoring by grouping. So I'm going to have, this is just y equals. So I'm just going to be looking at this part right here to try to factor. So I'm going to look at x cubed minus 5x squared plus 5x minus 4. Because it's an even number of terms, I'm going to try to factor by grouping. Common factor, greatest common factor of the first half is x squared. If I divide x squared out of both terms, x cubed divided by x squared gives me x. Negative 5x squared divided by x squared gives me negative 5. And then I see there's nothing I can factor out here except 1. And that gives me 5x minus 4. So now I see I have a problem. And the problem is that these two binomials need to be the same. And they're not the same. So because these are not the same, then that means I can't factor. Okay? But I can get all 3 roots. So I'm kind of stuck here. So then the next thing I'm going to do is I'm going to graph this function in my calculator. So I'm going to go to the y equals. I'm going to put in x cubed minus 5x plus 5x minus 4. And I graph it. And I see that I have a 0 right here. So I'm going to double check to make sure that that's in fact a 0. And I'm going to go to second table and I'm going to look for where y is 0. And right here I see that when x is 4, y is 0. So I know that I have a 0 at x equals 4. Okay? But that's only one of them, which means I'm missing 2 more because I have to have a total of 3. So that means that I'm missing 2 roots. So when I look at my graph, I can see that if this is my x-axis, this is my y-axis, my function is coming up, it's going down, and then it's coming up. It's only going to be able to give me 1 real root. Okay? So that means there has to be another way for me to find what the other root is. And there is. And it's called synthetic division. So that's the process that I'm going to introduce now. Synthetic division. Okay, so this is something that you're going to need to know how to do. It comes in handy, especially with situations like this. So I'm going to go ahead and I'm going to write down my function again. Instead of writing g of x, I'm just going to write y. So y is equal to x cubed minus 5x squared plus 5x minus 4. And I know that x equals 4. This here is my 0. Okay? So there's a couple things that I have to do. So synthetic is kind of like artificial. Don't panic over division. This actually is not a complicated thing to do. So the first thing I'm going to do is I'm going to look at just my coefficients. So what are my coefficients? Coefficients are the numbers that happened in front of the variable along with the constant. Okay? So I have to understand that there's a 1 here. And the other thing that I have to make sure is that my exponents descend in order. So this is 3, 2, 1, and none. So it's in standard form, and I have all my x's there. Something else, we need to do a placeholder if I'm missing one of these, and we'll look at that in another video. So I'm going to write my coefficients. 1, negative 5, 5, negative 4. Then I'm going to do this upside down kind of box like that. Then I'm going to take my 0 and I'm going to place my 0 here. Okay, so that's the setup. Then the next thing I'm going to do is I'm going to take this 1 and I'm just going to write it right here. So whatever number's here, I just copy it here. So this is kind of similar to the box in the sense where I multiply the outsides and add the inside. Okay? So that means I'm going to do 4 times 1, which is 4. Then these are on the inside, so I add them. So negative 5 and 4 is 1. Excuse me, negative 1. Then I'm going to multiply 4 times negative 1. I get negative 4. And then I'm going to add 5 and negative 4. And I get 1. Then I multiply 4 times 1. And I get 4. And then I add negative 4 and 4. And I get 0. This last part, I'm going to box off like that, because this is considered my remainder. And we'll have to know more about this later in different kinds of problems. But that's my remainder. So what you need to remember is the remainder must be 0 if x equals 4 is a root. If I tell you it's a root, or you find it's a root in the calculator and this doesn't come out to 0, that means you made a mistake. Okay, so because it's synthetic, it's not in a real form. So this is how I remember how to do it. This boxed in is my remainder. This number to the left of that is my constant. This is my x term, and this is my x squared term. So that means I have 1x squared minus x plus 1. Okay? So these numbers here have to be written like this. So what this means is that this here is a factor. So what did I have? I had if I had x equals 4, that means a factor of that is x minus 4. So if I were to take x minus 4 times x squared minus x plus 1, that would give me x cubed minus 5x squared plus 5x minus 4. Okay? So that means that these two, the number on the top and the number on the bottom, are equivalent. These are factors. Okay, that was my original. But I'm looking for the zeros. So remember, 4 was one of my zeros. That was a root. So I have to find the other ones. which means now I need to factor this. Okay, I'm going to factor the factor. One's a verb, one's a noun. So I'm going to try to factor this. Let me do this over here. So I'm going to set up my x thing. I'm going to do the first times the last, which gives me x squared, and I have negative x in the middle. So I know my factors of x squared are x times x. But these two have to add to negative 1x. If I have 1 and 1x, it multiplies x squared, but it doesn't add to negative x. If I have negative negative, it multiplies the x squared, but it doesn't add to negative x. So this here is cannot do. Go like that. That cannot do. It's not factorable, which makes sense. Okay? So we can't factor. Okay? But if we notice, this is what kind of function? It's a quadratic, which means we can find the roots, which happen to be imaginary, using the quadratic, you know it's coming, formula. Okay, and the quadratic formula is x equals negative b plus or minus square root, b squared minus 4ac, that's a b squared, got ahead of myself, all over 2a. So that means we're going to substitute our a, b, and c from this factor of our original into our quadratic formula. So I know that a is 1, b is negative 1, and c is 1. Get that right here. A is 1, b is negative 1, and c is 1. That means then that I'm going to say x is equal to negative b is negative 1, plus or minus the square root of b squared minus 4ac. It's kind of nice having all those ones. It makes it actually a little easier. All over 2 times 1. So that means I have x is equal to 1 plus or minus, clean up that square root in a minute, and I'm going to put 2 there in the denominator. So just to make it clean and easy, I'm going to put it in my calculator, straight up, parentheses negative 1 squared minus 4 times 1 times 1. Okay? I put the discriminant in, and I get negative 3. Well, that is still under the radical. So we can see we got an imaginary root. That means I have x is equal to 1 plus or minus the square root of 3i over 2. This is 2 roots. This is the root 1 plus square root of 3 over I, square root of 3 times I over 2, and 1 minus square root of 3i divided by 2. So this is my 2 imaginary, and I had my other real. So that's for a total of 3 roots.